Okay, so we're continuing on with the two-sample t-test. And we're going to look at one special case. It's usually the case that people use it for most, is this case, where the null hypothesis says the two groups come from populations with the same mean. So it says there's no difference between the performance or the observations in the two populations on average. And we took a sample for each population. We're trying to see whether there's some kind of a difference. So this could be, here's the alternative. The two means are different. So if I don't have any reason to suspect one kind of difference over another, I'm just wondering, is there a difference? That would be my alternative. I might be thinking the mean of population 1 is less than the mean of population 2. I want to prove that it's not equal, it's actually less. Or here the null hypothesis is equal, it's not equal, it's actually greater. Mu1 is actually greater than mu2. So what that does to the test statistic, here's t here. If mu1 equals mu2, it looks like this. So we'll be computing that for t. And then as usual, the two-tailed test, which is this case here, mu1 not equal to mu2 for HA. Then you would take your test statistic value, maybe it's here, and you would then take the sum of the two areas to get the p-value is the sum of two tail areas. Like that. So if you're using tables, you look to see where your t is. Tables only list positive values, so you just jump over here if it was negative. And you try to estimate what the tail area is, and then you double it because it's the same two symmetrically placed tail areas that give you the p-value. If you have a two-tailed test, that says the alternative is not equal to. Otherwise, if you say mu1, I think mu1 is just less than mu2, then I would expect these differences here to be mostly negative. I expect to get negative answers to favor the alternative. So for that lower tail test, it says mu1 less than mu2. Then in the T shape, we would find my pen not working. We find the T value and we just shade left like that. And for the upper tail test, for this is mu1 exceeds mu2, then I expect these to be positive to favor the alternative. So big T values. And so we would come over here with T is up here and we shade that side for a p-value. P-values, left tail and right tail. Okay, so that's the game that we're going to play in a minute. We're going to do it with the data you've seen on your sheet, so it's reproduced here again. So this data is the data collected from the migraine experiment, and you randomly divided the subjects into two treatment groups. The first group got medication 1, second one got medication 2. These are a number of minutes that it took to achieve relief from migraine with medication 1, with medication 2. And there's 15 in each group. And I computed the means. It's 104.93 here. And the standard deviation 13.9, and here the mean is 129.07. Here the standard deviation was 19.42. So naturally I had gone in my calculator. Uh-oh, battery is low. This is bad. We're going to try to survive this slide without the battery dying. If it does, I'll start over. That's sad. I could maybe plug this into something. Hang on. I'm not going to be able to find it fast enough. Okay, we'll just worry about that as it goes. Ordinarily, you've got some spare time. So stat, edit. So over here, let me zoom in a little bit. So in list 1, I've got all those values. And in list 2, I've got these other values ending up with 136 at the end. Oh, sorry. Scroll down here. So this one ends with 136. There it is. The other one ends with 90. Yeah, okay, so those look like the right ones. So I'll get out of here. We're gonna check normality. It says check normality. Okay, so I want to make a normal probability plot. So I'm gonna go to stat plot, second stat plot. I'm gonna go into the first one there. And it's already set up. This is the stat plot box. I picked list one. Let's go down and look. So that should be right. I'll go back to stat plot. I got something else turned on here. I'll go in here. That's the other stat plot. I'm gonna turn it off so that I don't see both of them at the same time. I'm gonna go to graph. I'm gonna go to zoom stat. There it is. So we're looking for is something that doesn't show a distinct curve. It can have wiggles. So that's for list one, the medication one. Okay. No distinct giant curves. Sample size of 15 is kind of big-ish, but we don't see a sweeping curve, so it's not skewed. That's nice. And then I'll do the same thing. I'll go to stat plot here. Let's go in there and turn this one off. I'll go back to stat plot. Go to 2 here. Now at 2, I turn it on. This one I've aimed it at list 2. Still using a stat plot. And then I'll just grab that. And I'll zoom stat that. Zoom. Go down to zoom stat so I can see it all. Didn't work. Heavens. I'm worried now. Oh, there we go. So that one is just beautiful. Yeah, that's amazingly straight. That's fine. Okay. And then we're going to compute a confidence interval. First, we'll do it by hand. So the confidence interval is for mu1 minus mu2. So what it looks like, I guess we're going to call this x1 and x2 here. Like that. So it's x1 bar minus x2 bar plus or minus t alpha over 2. And I've got this horrible thing here, s1 squared over n1. S2 squared over n2, like that. So I'm going to need a t value. I'm looking around my office for a t table. I think I left it in the other room. That's not pleasant. Maybe I've got one sitting right here just by accident next to my pile of stuff. I'm praying there might be one. I just don't see one. Well, fine. Maybe we'll just come back in a minute and do. I'm gonna, my calculator's going around it in a second too, so maybe I should get rid of that stuff. I don't know. Let's go ahead and that's what it would look like. I haven't computed all the things. I'll come back later and do that, and we'll do the test. We'll do it in the calculator, okay? Before we run out of juice. So we go to stat tests, 2 sample t test. Okay. And then we have to decide if it's data or stats. So we've got the raw data that's in list 1 and list 2. I did that. And then we want the not equal to alternative. Okay, so because we're looking for a difference. We don't have picked a particular kind of difference. So HA is mu1 not equal to mu2. Like that. And so there it is. I picked that. Down here it says pooled. Pooled is a way of estimating this standard deviation that's different from this. It's not recommended to be used. So I just say no. And then go to calculate. So what it says is t is minus 3.91. Now we know that is a giant number as far as t is concerned, which means you're going to reject the null hypothesis. Reject HO. And the claim is mu1 is not equal to mu2, like that. The p-value, it's 6 times 10 to the minus 4. 1, 2, 3, 4, like that. 6, then move it over 1, 2, 3 for the decimal point. Okay, so there's the p-value. It's really tiny. And so we'll say up here, clear evidence that mu1 is not equal to mu2. So the two treatments are not the same. Two treatments cannot be considered about the same. And I guess we'd like to know how different they are. So if we had computed this, we could do that, but I'll ask the calculator to do it as long as I'm here. We'll go to stat. I'm going to run out of space here. Clear. We're going to go to stat. Where'd it go? Stat. Tests. Two sample t interval. That's what we need. List 1, list 2. I'm going to do 95%. That's pretty much the default. Coming down here. So it's going to compute this using a critical value from 95%. Here it comes. The confidence interval looks like minus 36.82 up to minus 11.44. So that says this difference here is most likely negative, which says that, this difference in me is most likely negative. So this number here is larger than that number there. So that means it took longer to have relief with medication 2 than medication 1. So we're thinking it looks like medication 1 is better, has shorter times, so shorter relief times. So we did that. So what I'm going to do is I'm going to stop the recording and then I'll come back, make sure my calculator is working. And we'll do some of these calculations like this stuff here. I'm computing this t-value by hand. So here we go. I'm going to pause this. I'll be here in a second though. Don't worry about that. I'm just going to say stop recording.